scientists have discovered dozens of exoplanets in the habitable zones where liquid water could exist. These planets, which resemble Earth in size and temperature, might support life. While we haven't yet found direct evidence of life on these exoplanets, the sheer number of potentially habitable worlds suggests that life could be very common in the universe than we ever imagined. But what if the answer to one of humanity's greatest questions, are we alone in the universe, lies not in the distant reaches of space, but right here in our own cosmic backyard? Imagine for a moment that life could already exist, or could have once existed, on one of the many worlds within our solar system. What if the secret to answering this age-old question has been hidden in plain sight, not in a galaxy far away, but on a moon orbiting Jupiter or beneath the surface of Mars? With cutting-edge technology, the search for microbial life within our solar system has become one of the most intriguing areas of study in planetary science. How incredible would it be to discover that the nearest place where life exists outside Earth is within our solar system, and not on some exoplanet light years away? In the frigid ice of Europa or beneath the dusty surface of Mars, something once lived or might still live today. These discoveries would not only redefine our understanding of life's existence, but would also bring us one step closer to answering the fundamental question, are we truly alone in the universe? This is the story of our search for life beyond Earth, a search that's taking place in places we may not have expected, right here in our solar system. So, where could life be hiding, and how do we know it's possible? The search for life within our solar system is one of the most exciting areas of research in modern science. It is not only about discovering extraterrestrial life, but also about understanding the unique conditions that make Earth habitable. By studying the places where life might exist within our solar system, scientists can gain deeper insights into what makes a planet or moon capable of supporting life. Let's start with Mars, the red planet. Mars has long been a top contender in the search for life. The reason Mars garners so much attention is its geological history, which suggests that it may have once had liquid water on its surface. In the distant past, Mars had flowing rivers and lakes, and scientists believe it may have had a warmer, wetter climate. This raises the question, if Mars once had the right conditions for life, could microbial life have emerged there? Mars's past climate suggests it could have been hospitable to primitive life forms in the past. Evidence of ancient riverbeds, dried up lakes, and minerals that form in the presence of water hint at a time when water was abundant on Mars. However, today, Mars is a cold, dry world, but it still has signs of water frozen at the poles and possibly in liquid form beneath the surface. Rovers like Perseverance and Curiosity have been instrumental in analyzing rocks and soil to find evidence of microbial life. Scientists have even detected methane spikes in the Martian atmosphere. Methane, a gas associated with biological activity on Earth, could be a clue that microbial life once thrived on Mars, or perhaps it still exists in some dormant form beneath the surface. The evidence is tantalizing, and each new discovery brings us closer to understanding whether life ever existed on Mars, or if it could exist again. Next, let's look to Europa, one of Jupiter's moons. Beneath its icy shell lies a vast subsurface ocean kept warm by tidal forces from Jupiter's immense gravity. This ocean might be in contact with the rocky mantle, creating conditions similar to Earth's deep ocean vents, where life thrives in the absence of sunlight. The internal ocean of Europa could be rich in minerals and energy, which are essential for sustaining life. Scientists believe that these molecules, combined with liquid water and energy from tidal forces, could create an environment where life, perhaps in the form of simple microorganisms, could survive. Europa's surface even contains organic molecules, essential building blocks for life. These organic molecules have been detected in the moon's surface material by spacecraft like the Galileo orbiter, further strengthening the case for the potential of life. With NASA's Europa Clipper mission coming up, this moon is a prime target in the search for extraterrestrial life. Europa's ocean may hold the key to understanding whether life can thrive in extreme environments, much like the organisms that survive at the bottom of Earth's oceans, far from the warmth of the sun. And what about Enceladus, Saturn's icy moon? Enceladus is not just a frozen ball of rock, it's a world alive with geysers that shoot water vapor and organic molecules into space. These plumes suggest a subsurface ocean in contact with the moon's rocky core. And scientists have detected amino acids in the water. Amino acids are the building blocks of proteins, which are crucial for life. The presence of these organic molecules in the water vapor ejected by Enceladus is one of the strongest pieces of evidence suggesting that the moon might harbor conditions suitable for life. Enceladus ocean is in direct contact with the moon's core, where hydrothermal activity could provide the chemical reactions necessary to support life. The geysers, which are spewing water and organic material into space, allow scientists to study the moon's subsurface without having to land on it. This makes Enceladus a more accessible target in the search for life than many other moons and planets. The possibility of life existing on Enceladus has made it one of the top candidates in the search for extraterrestrial organisms in our solar system. But wait, there's more. Triton, Saturn's largest moon, is a completely different kind of place. Triton's surface is cold, with lakes and rivers of liquid methane, but it has an atmosphere thick with nitrogen and methane, chemicals that could create conditions for life forms very different from anything we know. Triton is unique because, despite its freezing temperatures, it possesses a thick atmosphere, which makes it one of the few bodies in the solar system with a dense, nitrogen-rich atmosphere. The atmosphere contains hydrocarbons, and scientists believe these could serve as a solvent for life in place of water. Triton's surface also holds complex organic molecules, key ingredients for life. The presence of these molecules, along with liquid methane lakes, suggests that life could potentially emerge in a completely different form than on Earth. Triton's unique chemistry could allow for life forms that don't depend on water but on methane or ethane instead. NASA's Dragonfly mission, launching in the 2030s, will send a drone to explore Triton's surface and atmosphere, looking for signs of prebiotic chemistry. This mission will give us a closer look at Triton's lakes and seas and could provide crucial insights into whether life can emerge in environments vastly different from Earth. Venus, long thought to be too hot for life, has recently sparked renewed interest. While the surface of Venus is a blistering 450 degrees Celsius, the upper atmosphere 50 kilometers above the surface has far more temperate conditions. In 2020, scientists detected phosphine gas in Venus' atmosphere, something typically associated with biological processes. Phosphine is a gas that, on Earth, is primarily produced by certain types of bacteria. The discovery was groundbreaking because it suggested that Venus might harbor microbial life in its clouds, where temperatures are far more hospitable than on the surface. This has led to renewed interest in studying Venus' atmosphere to understand how life might survive in such extreme conditions. The idea that life could exist in Venus's clouds seems almost impossible given the planet's scorching surface. But the discovery of phosphine has opened the door to the possibility that life could exist in the more temperate, cloud-covered regions of Venus. This has led to further missions to study Venus's atmosphere, as scientists seek to understand how life might survive in such an inhospitable environment. Then there's Ceres, the largest object in the asteroid belt. This dwarf planet has large amounts of water, ice, and some evidence suggests that liquid water could exist beneath its surface. Ceres is considered one of the most intriguing objects in the asteroid belt because it holds the potential for subsurface water, which is a critical element for life. With organic molecules present, Ceres could have the right ingredients for life. The Dawn mission, which studied Ceres until 2018, uncovered intriguing bright spots on its surface. Could these be connected to subsurface water? These bright spots, which are believed to be salt deposits, could indicate past or present water activity on the dwarf planet. Ceres lies in the habitable zone of the solar system, where conditions might allow for the presence of water, a crucial ingredient for life. While Ceres doesn't have the dramatic geological activity of Europa or Enceladus, its potential to harbor liquid water beneath its surface makes it a compelling candidate in the search for extraterrestrial life. Triton, Neptune's largest moon, is another place where life might be hiding. Triton's surface is cold and icy, but it has geysers that erupt nitrogen gas and water vapor, hinting at active geology beneath its surface. These geysers suggest the possibility of a subsurface ocean, much like Europa and Enceladus, where conditions could be suitable for life. Triton's geysers may be creating the right conditions for life, much like the deep-sea hydrothermal vents on Earth, where life thrives without sunlight. And the possibility of liquid water beneath the surface makes it an intriguing target for future exploration. While much of Triton's potential for life is still speculative, the presence of water, energy, and organic molecules could make it a prime candidate for missions aimed at discovering life beyond Earth. One thing is clear: the search for life in our solar system is just beginning. Mars, Europa, Enceladus, Titan, Venus, Ceres, and Triton all offer compelling clues that life might have once existed or could still be thriving. As technology advances and new missions launch, we may be on the cusp of one of the greatest discoveries in human history: the discovery of life beyond Earth, right here within our own solar system. Do you think it will happen this century? Share your thoughts in the comments. Welcome to Sagacity section. Thank you for watching, and I'll see you in the next one.